But now I will let the stage to Laurent Gabet to get a deep dive into this development of this new product here at Airbus.
Okay, thanks, Victor. Hello, everybody. So I'm Laurent Gabet, the head of the R&D team. So I will introduce our work, the Pléiades Neo HD15 AI module. I will go through the presentation in 3 steps. First of all, we jump in the data, so you will discover what is really Pléiades Neo HD15 at a large scale. And then we will see the limits, what you can expect from it and what you should not. And then finally, I will introduce the technology so like that you will become comfortable with it. It's quite easy to understand, even if it's quite complex to set up. Okay, let's start by the first part. So we will discover together a mosaic of Pléiades Neo HD15 over Bordeaux. So I've picked this example because it's just to introduce the fact that when you are ordering a Pléiades Neo HD15, it's like ordering a Pléiades Neo. In this case, we have 6 images, and you can enter those images, the primary bundle, or those in your own pipelines, and you can run the processing as it was a standard Pléiades Neo image. So very easy to go, very easy to manage. So let's zoom in. The objective of this demonstration is to show the difference between Pléiades Neo and Pléiades Neo HD15. So we can go in any area in this part. So if we go here, by example, so what we are looking currently is the Pléiades Neo mosaic. So you see, and it's quite cool. Pléiades Neo is a very good sensor, but if we apply the Pléiades Neo HD15 processing, that's what we will get. That's what you will get. So I'm going to go back and forth on the image just for you to see what you can get from the imagery. So you see the lines; they are a little bit sharper. You can see the structure in this building also a little bit sharper. We will see later on that no information has been added, which has not been recorded by the original sensor at 30 centimeter, but the looking is far nicer. So if I'm scrolling in the database, so going back and forth to the imagery, so you can see that the benefit here is it's easier, you are more comfortable in looking at the imagery, in interpreting it. That's what really Pléiades Neo images is bringing. You can see the structure. So maybe I should move in another area where there is more interesting things to look at. I don't know, why not here? Okay, that's a parking lot. So in this parking lot, if you look at here, you see the different specific parking for the pregnant ladies, or I don't know, but whatever. So I think you are getting really the information. So now I will switch to switch back to the presentation, and we will look at what are the specificities of Pléiades Neo. Okay, so here I will introduce 3 different images. A Pléiades Neo image that you have just in front of you, and look at the blue circles. So the blue circles are to show where you can expect the benefit. Then I will go to the Pléiades Neo HD15, so go back and forth to the 2 images. So you can see the improvement. It's like you have, the lines are sharper. It's easier to interpret if you look at on the roof. And now look at the red circle. What I will introduce now, it's a Pléiades Neo HD15 compared with an aerial image acquired at 15 centimeter. So what I'm calling the ground truth. And if you look in the red circle, you will see details that are available at a real a 15 centimeter image acquired with an aerial sensor, and what you will get in Pléiades Neo HD15. So it is just to give you, so there is small details which are not there, and it's normal because we don't invent any information, and that's our duty and that's our goal. If I go back to the Pléiades Neo, if you look at the small details, you see that the signal, there was no information on those small parts. And so we don't invent anything. We keep it as it is in order to be on the safe side. So no big deal. There is some limits, but it's normal. Our satellite is flying at 600 kilometers away. We are enhancing the quality of the imagery. It's easier to interpret it. You are more comfortable, but we cannot expect. It's not like an aircraft flying at 6,000 meters or 6 kilometers, something like that. Okay. So now it's the time for you to understand the technology, and so it's very easy, in fact. But we went through a specific path, and the specific path is based on a simulation only. So the AI model that we have developed, it's certainly a neuronal network, but we developed it and we constrain it in order to avoid creating wrong information in the 15 centimeter, which would be an issue for us because you would not be able to believe in this image. So we have developed this model with our colleagues from Space System. Those guys have developed the satellite and developed the optic, developed the sensor. So they are the one which know best the satellite. And thanks to this collaboration and thanks to their capacity to simulate the Pléiades Neo image, we have been able to develop a so sharp HD enhancement AI algorithm. So we start from aerial images. So we have aerial images from 5 to 8 centimeters. We take this aerial image and we create we are using them to create the labels. So it's a fully supervised AI approach. So we create the labels. One label will be the Pléiades Neo image. So we use the simulator, the real one, which has been used to create the sensor. But we also, with the same image, we will create what we would like to have, like a satellite at 15 centimeter. So from one data, we create 30 centimeter and 15 centimeter. It's exactly the same data set. There is not at all any difference, except that one is at 30 centimeter resolution, the other is at 15 centimeter resolution. And that's where the trick is, because then we don't give any opportunity to the AI model during the training process to invent something, because he has no way to do that. He has on the 30 centimeter image, you have a line which is a kind of blurry at 30 centimeter, and it's sharper at 15 centimeter. It's exactly the same thing. So that's the beauty of our approach. Okay, so at this stage, I think you have completely understood the approach. So let's look at some images. So here, that's an example of an aerial image at 5 to 8 centimeter. We have our simulation engine. We apply the simulation engine to this image, and we produce the two images that I just described earlier. So the Pléiades Neo on the upper side, and what we are looking for at 15 centimeter, the enhanced one on the bottom side. Then we create a very large data set, training data set with this methodology worldwide in forests, is different landscape, certainly. And then we put them we train our AI model, the neuronal network, using this supervised label data set. And okay, we run it. And at the end of the day, he will understand when we give him an image like that, he will bring the image like that, which is 30 to 15 centimeter, and the job is done. So that's quite cool. Before moving to some examples, I would like to show you the important point for us is the capacity to simulate properly the Pléiades Neo image from the aerial image, because that's where the difficulty is. But we are able to do it because our colleagues from Space Systems, which developed the satellites, they know exactly any specification of this sensor. So on the top, you see a simulated image from an aerial data, and on the bottom, it's a real Pléiades Neo image. And you can see, okay, except that the data are different, but you can see that it's very difficult to see any difference, and that's why our system is working. Okay, so I'm done for the technology. If we can go back to some results, we have developed in fact two AI models, one for the panchromatic and one for the multispectral. So when you are ordering a primary bundle product, the HG will be applied on the panchromatic and will be applied on the multispectral. So when you get this data, you do the pan sharpening with your own algorithm. It will work as in a standard mode for you. So if you look at the courtyard, the left image, okay, so you see the lines which is far sharper. You can see the children hanging around in the courtyard. In the middle set of images, okay, it's visible. The name is visible on Pléiades, but far easier to read it in the Pléiades Neo HD. And if you look on the right side, on the Saudia airplane, so with Pléiades Neo, okay, a specialist will read Saudia, but okay, a specialist, but for everybody, it will be easier to look at Saudia in the Pléiades Neo HD 15. Okay, I'm done. I have finished my presentation. Just for your knowledge, we have written a scientific article which has been introduced at the ESPRS Congress in 2022. So you can go and grab it and go through it. So you will have all the details of our implementation. So it's time for me.
May just add something. You can order bundle primary, but also ortho pan sharpen directly on one atlas.
Yes, you're right.
So don't need to pan sharpen by your own if you are not used to.
Yes, you're fully right.
So thank you very much, Laurent.